Thank you for this opportunity to talk about LED solid-state lighting market. This is a market that's just in its infancy. It is growing rapidly, and we expect this to be a huge market for analog semiconductors over the next few years. In fact, for the next decade. So let's talk about why this is such an exciting market. This is not only a market, try this one. All right, so this is not only a market that's economically justifies its existence and is a great opportunity, but environmentally it's also. We look at it as a way of saving energy, saving money, cutting CO2, and we actually believe at iWatt that when people talk about where are we going to get the energy going forward for the expanding middle class, that's the wrong place to start. Where we should be starting is how do we cut back on the energy we're using today. So one of the ways we can do that is by having a more efficient lighting. So as you can see, lighting is a large portion, and these statistics are in the US, but we take this as sort of a stalking horse for the rest of the world. The rest of the world is expanding and adopting a lot of, I guess, US and Europe's bad habits of using a lot of energy. But if you take a look at lighting in the US, it is about 11% of all residential energy. And so this includes gas, natural gas, coal, oil, used in the home, and lighting and other applications. Commercial energy is about 20% is used in lighting. If you look at it from an electricity standpoint, about 25 to 30% of all electricity is used for lighting. So if we could eliminate, say, 90% of that, then you would save up, basically you could shut down 25% of all the power plants in the United States. Or you could reallocate that energy for charging car batteries, powering electric trains, et cetera, and eliminating a lot of carbon-based fuels. So if you take a look at energy efficiency, global tightening of energy efficiency standards and regulation is becoming more and more prevalent. The governments know that the world needs to change. We need to change the way we're using energy. And so even the state of California has its own standards. Canada does, US, and all major governmental agencies have tighter standards. And so these standards make it a great opportunity for analog companies to deliver more and more efficient solutions to the marketplace. So one alternative to LED lighting is CFLs, compact fluorescents. Well, we don't need to replace an excess of energy use with another ecological disaster, which would be mercury. CFLs have mercury, and if you take a look at how much damage CFLs can do, 1 teaspoon of mercury can pollute a 20-acre lake forever. In the United States, each year there are 600 million fluorescent lamps disposed in US landfills. This is 30,000 pounds of mercury waste. And so if it's taken care of efficiently, it won't cause harm, but when light bulbs burn out, they get thrown into trash, and it ends up in landfills and can end up being an ecological disaster. And just another example is that mercury from 1 fluorescent bulb can pollute 6,000 gallons of water beyond safe drinking. So this is a huge problem, and it says that where energy standards are set without considering what can happen as some of the consequences, they can make an even larger problem. So we believe LED lighting is a far better solution. And right now the only solution as far as driving energy efficiency going forward. So on this slide we talk about light output in an incandescent bulb, 15 lumens per watt. So that's a 60-watt bulb. An LED lamp at 75 lumens per watt is the equivalent, give you the equivalent of a 12-watt LED provides the lighting of a 60-watt incandescent. And so the 12-watt lamp replaces the 60-watt incandescent. And the lifetime of the incandescent is about 1,000 hours. For an LED lamp, it can be 25,000 hours. That's the life of the LED. Now we're going to talk a little bit more. One of the things that we need to do is provide drivers that are reliable as the LEDs. Right now, the failure rate on LED lamps is 1,000 ppm within 6 months of sale. And so there are problems in this supply chain and technology chain that need to be solved, and we'll talk more about those. The cost of an incandescent bulb is very cheap. People have sticker shock when they walk in and see $30. But if you do the math, with the power savings that you get, you end up paying for that bulb in 2 years. So by using an LED lamp, even at $30, you can pay for it within 2 years because of the lower power consumption. Now, as we point out down here, that's $30 now. 60-watt lamps are quickly approaching $20, moving to $10, and so that payback will be in months, not years, very soon. And so it's an opportunity to clearly show that incandescent bulbs are no longer needed and that we're actually better off, the consumer is better off, but it takes a lot of education to convince the consumer that they're actually better off. The consumer typically walks into the store, see lamp, $1, incandescent bulb, $1, LED, $30. It's no way it will pay for itself. In reality, it does. And so by having LEDs consume 5 times less power, the bulb lasts 20 times as long as we do our jobs. Advanced control, remote monitoring. There's actually discussions about having Wi-Fi repeaters in the bulb, various other technology incorporated in the bulb, smoke detectors, etc., that with the intelligence you can put into an LED light, you can actually have a better product overall. And the legislative bans basically start taking effect significantly in 2012. Australia is already banning incandescents. Ireland and others have already done so. In the US in 2012, incandescent bulbs start going away. So, it'll take time for them to all go away, but that trend has already started. And we talked about 75 lumens per watt. That's just the start. Right now, you can see that, and this is from Osram, their projections are that we'll be approaching the physical limit of 300 lumens per watt in 2020. And so we know that there's already been demonstrations done of 180 lumens per watt, and that they'll become commercially viable in the next year or two. And so at that point, LEDs are a better solution than all conventional lighting sources. So it's time to start moving to the new generation of lighting, which is LEDs. And so when LEDs were invented, as in any high-tech environment, they're very expensive because of a lot of research, low volumes. Now we're in the LED lighting adoption zone, where the cost of LEDs are dropping below $10, and this curve continues down. But with government regulation, we think this is the natural curve on technology learning curve. It's like flash memory coming down on this type of curve. If government regulations pull ahead the learning curve, this will curve down, and we'll be pricing LEDs in pennies rather than in dollars in just a few years. So that is going to open up a huge market. And so LEDs are used in many areas, and it's growing. The biggest area is in signs and displays. You can see that TVs and other displays are using most LEDs and are projected to continue to use the most LEDs. LED solid-state lighting illumination is growing very rapidly. And so this we see as a trend, and quite frankly, from my experience, I think this is probably conservative. And we'll talk about why that is. And so Philips' projections are that conventional lighting is basically going away quickly. LED lighting is taking over. And so as you can see, that this trend is rapidly accelerating, and we expect that it will continue over the next few years. So it's a $100 billion market right now. The market is very geographically distributed. Asia is the largest portion of the market. Europe, Middle East, Africa is next, and the US is, in North America is a significant portion. But there are 25 billion incandescent sockets in the world. So this is basically made up of replacing those incandescent sockets over and over, bulbs over and over again. There's a very fragmented top 10 lighting luminaires. So in the LED market, there's a lot of different companies, and we'll talk about that in the next couple of slides. But think about 25 billion incandescent sockets, and if all those have to be populated by LED bulbs over the next 5 years, you're talking 5 billion sockets per year on average. This year we're estimating 160 million units. Next year we think it could grow to 360 to 500 million units. Think of the ramp getting to 5 billion per year. So that's a lot of LEDs, it's a lot of LED drivers, and a lot of components to support this business. Leaders in this market are the usual suspects, Osram, Philips, GE, Civilite, Cree has been strong. These are US-based companies that are doing LED lights. And there are over 500 lighting manufacturers outside China. We estimate about 1,000 inside China. So this is a very fragmented market, and we expect it to consolidate. And some of the winners we expect could be the ones that vertically integrate. Philips Lumileds make LEDs, so does Nisha, Epistar. We expect Samsung and LG to also. In fact, if I was talking to someone earlier, and we believe at iWatt, and members of my board, one more board member sits on 6 different LED companies. And he said the winners of the consolidation, who's going to be number 1, number 2, at least in the top 5, are going to be Samsung and LG. They have the capability to have the foundries to create the LEDs. They have the marketing channels to sell the LEDs. They have the funding to develop the technology necessary to be leaders in this market. And so whenever used to be Sony and some other names were considered the top brand names. Samsung and LG are the top brand names in the US and Europe and many other areas now. And we expect that they are ideally situated to take advantage of the trends in LEDs. Not only LED solid state lighting, but also in displays. So a great future for Korea, especially with such strong companies as Samsung and LG that we know are now focusing in on this market. So that's sort of broad marketing trends. And so I'm going to now talk about some of the technology involved with these products and spend some time on where the adoption is going to be first and what are some of the risks to this market. So the first place that LED lighting is really gaining traction is in street lights. It takes a lot of money to bring a truck out, have a person come out and replace one of these lamps. And if it burns out after 1,000 hours or 2,000 hours, that's extremely costly. And so the beauty of this market is that if the LED lamp can exist in this environment, being outdoors and is reliable and has a long life, then it will be very easy to adapt it to residential and commercial applications indoors. So the high reliability is needed is 50,000 hours lifetime, no electrolytic capacitor, less inrush current, immunity to lightning surge, so you have to deal with surge protection with these designs, save more energy with higher efficiency, so a very high power factor, high power efficiency at 90%, and built-in digital communications. As you can see from this picture, you can put solar panels on these and disconnect these from the grid. And basically, because of the low power consumption, you can drive those off from solar energy and store the energy overnight and use the solar energy to drive these street lights. Low maintenance with modularization, we'll talk a little bit more about that. And then low cost structure design for single power design, simple, reliable, and LED modulation for maintenance. These are flexible, have to be flexible, 5 watt, 100 watt, 150 up to 200 watt LED lamps. And so those are very bright. It's equivalent to 1,000 watt typical standard lamps. So there's different ways of approaching this market. One is to have ACN, EMI, and PFC, and then a DC-DC converter driving DC to these different modules, which creates a point of failure at this point. Again, it needs to be reliable, and so you want to eliminate this. A new architecture that's just being introduced is LED control modules, where you eliminate this point of failure and drive the modules directly from AC to DC using AC-DC converters. And so one of the beauties of this is that if one of these AC-DC converters fails, you still have 5 other modules. So if this fails, the whole light fails. And so this is a much more robust scheme, and it's just being introduced. And so a lot of opportunity for innovation in this marketplace. We'll talk a little bit more about why the conventional is less attractive than the LCM approach. The cost, the DC-DC module, when you add up all the cost, is about $16 as opposed to less than $15 using the LCM approach. So lower BOM costs, higher efficiency. There are fewer components, fewer areas for efficiency to be lost. The assembly, the main converter needs to be scaled for different outputs. The main converter is formed by each individual module, so you have more flexibility. You have built-in over temperature, over voltage protection in each channel. And then you have you need actually additional components here, but it's built into the LCM approach. So you end up with higher reliability because instead of having 8 converters, you have 7 here, and the individual lamp failure rate is much lower than the failure rate for the conventional approach. Did I get that? Yeah. So one of the alternatives, one of the discussions that have been going on in the LED lighting world is AC LEDs versus DC LEDs. Whether you should drive directly from AC rather than converting from AC to DC. And so actually Seoul Semiconductor, Taiwan Institute of Technology has been pushing this approach. There are major benefits. You can operate on AC power without the need for a DC-DC converter. Does not require a transformer. It's low cost, compact size, and no electrostatic discharges. The AC LED limitations are lower luminous efficacy compared to DC. Since the AC-DC chip the AC LED chip works under high voltage and low current. Flicker, since AC LED operates at the dynamic VI range, it will be hard to balance the whole VI curve. And so when we say AC LED versus DC LED, we don't think it's one or the other. It depends on the application. The AC LED is best suited for low power spotlight. It's more practical, less than 3 watts, such as MR16s. And the DC LED is best suitable for the high power general lighting. Now, we've been talking about the benefits of analog, but there's also benefit to digital, and we believe that there's a middle ground of combining digital control and analog. So if we go through this animation again, a pure analog approach has more areas of failure. Secondary feedback, PFC control, etc. And you can basically eliminate those components by having a digital PFC product that reduces all these components and still has advanced analog interface to the outside world, but results in fewer components, higher efficiency, reduced size, and lower cost. So the form factor, because you want to fit in the base of a bulb, you want to have fewer components. And so it's not only a cost savings, it's a size savings, and it's efficiency savings. And so it's also a life savings because you don't have as many components that will fail. So we believe that having a digital PFC controller is a much more effective way of serving this market than having pure analog designs that include a lot more components. So another area of concern is the flicker that you get in LED lights. So there's an old song about New York, New York. If you can make it there, you can make it anywhere. Well, if you can make LED lamps for India, you can make them anywhere. The power grid is such that the power sag, power surge, etc., you do not want that destroying lamps. You do not want that causing flicker in your lamps. And so it's very important to have tight plus or minus LED current regulation for constant brightness and no flicker during line sag or surge. So this is very important, and flicker is one of those things that can get in the way of market. Our customers that we've talked to have said that it's not only visual flicker, but electronic flicker. So when you take a picture with a camera, you do not want to see flicker or your image destroyed. So you need to be able to provide very tight current regulation and be able to eliminate noise on the line through advanced technology. And again, the tight current regulation and constant brightness and no line flickering due to lag, sag, or surge is one of the things that we think is essential to the market, and another reason why we think this digital control approach makes it an easier solution. So, as I mentioned earlier, that the LED itself will last for 25,000 hours. But there's this large failure mode right now with lamps within the first 6 months, 1,000 ppm. So there are components that need to be replaced or just eliminated because they fail after 3,000 to 4,000 hours. Or if they don't fail, they can cause the LED to degrade. So basically, this is from Toshiba, the standard as far as the operating temperature. It has to be a wide range. With an optocoupler, it's a point of failure. And in fact, it's one of the ones that will fail after 3,000 to 4,000 hours. If it doesn't fail, you get a current transfer ratio that will change over time and temperature, high temperature. So over the high temperature range, you actually get degrading of the LED. So think about sitting in a room and you have two LED lamps. One is degrading faster than the other. You bought the bulbs at the same time. You could actually walk in and see differences between two different lamps when you bought the bulbs at the same time from the same company. And the reason for that is, the reason for that is the degradation that will occur in the LED. So the change in CTR can affect the stable operation of the power supply and actually result in power system failure. So most of our LED customers are actually phasing out the optocouplers. And so this is an area that uses primary side regulation and can eliminate the optocoupler and result in a much more robust system. Another issue is single stage versus two-stage power factor control. And so this approach is actually simpler, where we have just to have an optocoupler, and the cost, basically down here, high performance solution where the cost and size is not a concern. So if the form factor is big enough, then the single stage PFC makes sense. But it includes an optocoupler, its secondary control circuits increase size and cost. It requires high output caps and size, increases size. The high ripple current causes flickering, and so you run into a problem with just the viability of meeting the market needs. And so a lot of negatives in this area. And so as the market is changing, we're now moving more to two-stage PFC controllers, where you can eliminate the optocoupler with primary side regulation, reduce the size and cost and increase the lifetime, boost front stage for the high PFC and PWM driver with low output ripple, which means the flicker is much better. And so you can use a small output cap for reduced size. Low current increases ripple, increases the reliability. Discrete two-stage solution can increase size and cost by adding a MOSFET and some other smaller components. But the single-stage IC for two-stage solution is a good compromise. And so what you'll see going forward is the PFC and the PWM controller being integrated into one chip. And because of the small size, it will be able to fit into all lamps. So there's a hidden cost to LEDs. Right now, LEDs have been the focus of lowering costs, but the industry has done such a good job of lowering the cost that LEDs have now dropped to 35% of the cost of the fixture. 65% are the other components. The power supply, the LED drivers, the AC/DC chips, and other MOSFETs, et cetera, in the power supply, the mechanicals on the lamp, the drive current, the optics, the lenses, which is another story. Just being able to get a bulb where the light diffuses in a way that an incandescent bulb diffuses is one of those challenges to the industry also. So using more efficient LEDs lowers thermal, optics, and electronic costs and the total BOM costs. So the non-LED costs are becoming more and more important to improving the LED system cost per lumen. So we showed you the cost per lumen on the LEDs. It's dropping dramatically. And as the volumes go up, we expect these costs to drop also. Again, you move from 165 million units per year to 5 billion. It's a significant volume as far as economies of scale, and you end up with much lower cost in these mechanical apparatus that have to go along with the LED lighting. So those will come down over time, especially with all the competition. So the market needs for next generation LED drivers for this market to support the LEDs, high power factor correction. 0.9 is mandated by Korea. Is used in commercial applications. So it's important that we achieve this, this type of level, or suppliers achieve this level. Again, if the Samsung and LG are going to be the leaders in the market, they're looking at 0.9 PFC for the Korean market. That's what they want, and that's what they're going to use going forward for other markets. Seamless operations with all dimmers worldwide. This is an interesting challenge because there's basically 22 different dimmer functions in the world. And there are some dimmers, there's a Bush 6513, I believe, that actually looks like a trailing edge dimmer, becomes a leading edge dimmer, and the LED driver, the AC-DC driver, has to judge what driver is that's interfacing with the bulb. So you can't go through and say you're going to replace all the drivers on the wall. And so you have to work with the legacy dimmers. And so with new commercial applications, you can actually have less stringent requirements because you can design a driver for a specific dimmer class. But when you do retrofit, where most of the lamps are, you have to be able to work with 22 different types of dimmers. Leading edge, trailing edge, the triac dimmers with various functionality, and sophisticated programmable dimmers, etc. So this is a huge task, and from experience, what iWatt went through was we went to a large lighting company with an FPGA board, sat down with them and spent 2 weeks developing algorithms so that we could implement and work with all these different dimmers. And so it's a huge opportunity for digital control technology, and it's actually a challenge for a pure analog approach, but we believe with the digital control and analog that we have, we can work with all dimmers in the world. And we'll actually show you some of our products at the end that have benefited from this work. And so one of the things about a new market is you learn from each generation of product, and we're still in the learning stage on these products. So you need these products to be hot pluggable. You need multiple output drivers for color mixing. Again, one of the challenges is that the LED bulb has to replicate what the incandescent bulb does. And so if you have a certain color scheme that you're after, you have to be able to work with the LEDs and be able to work with the different color characteristics of the different LEDs. So driving fewer series connected high current, high brightness LEDs will require secondary side synchronous rectification. I guess one of the holy grails is to eliminate the electrolytic capacitor to increase lifetime. We talked about the optocoupler, and so you can eliminate the optocoupler. That's a point of weakness. The ECAP fails at about 8,000 hours. And so you can use ceramic caps, you can use technology to eliminate the electrolytic capacitor, but then you add other components that could also fail. And so we're still working at how do you eliminate the electrolytic capacitor in a way that's cost effective and provides a reliable alternative. And so that's, again, this is a new market. It's one of the issues that needs to be addressed, and will probably be the difference between how quickly you go from 165 million per year to 5 billion per year. The smaller form factor is important. You'll see a number of lamps that actually will stick out of the lighting fixture because they require heat sinks. So it's important that the the heat sink, or that you eliminate the heat sink and you can actually fit inside without exposing the lens in the application. So small form factor is very important. And again, as the LED cost drops to pennies, 10 cents to pennies, and you're talking about the LED drivers and all the other components have to reduce cost also. So lighting with LED, the value proposition that we see is you have to eliminate the optocoupler. You have to be small form factor. You need to fit in the base of the bulb and not require a heat sink, and you need to do that up to 25 watts and above. And so, some competitors actually fit in a 3-watt base, but above 3 watts, they actually have to add a heat sink. We think heat sinks are unnecessary. We believe the high reliability through open short protection, over voltage protection, current overshoot and soft start, current sense resistor protection. A lot of the things that in AC-DC adapters that we have to deal with, you also have to deal with in LED lighting. Meet all the safety requirements. There's a lot of requirements that have to be met. Having flexibility to meet the requirements in different jurisdictions is important. High power factor correction because you want to use as much of the power as possible. The long life MTBF, people don't want $30 bulbs failing. They don't want $10 bulbs failing. The dream sequence scenario is that you used to buy a lamp to put in your child's room and you replace the light bulb every year. Now the dream scenario is you buy an LED lamp and you put it in your child's room and you never replace the bulb until they leave for college. And so that's the goal of the industry, and that's what can happen with this type of improvement in mean time between failure. So small form factor versus competitors is important, high switching frequency. We actually are the exclusive in iPad adapters for 10-watt application because of our high frequency design, and we think that's essential for being successful in this market. And again, no visible flicker. Electronic flicker or visible flicker is not something that the market will tolerate. So as I mentioned, iWatt has been a leader in this marketplace. This product, our 3610, won the EDN Product of the Year award in 2010. We learned a lot from that product. We're introducing 3 new products this quarter. PF less than 0.9 and also PF above 0.9. We used to work with 2 to 100% dimming. Now we're 1 to 100% dimming. We continue to improve small form factor because of the high frequency, robust fault protection, etc. So iWatt can deliver. Most of what we were talking about is the holy grail already. Eliminating E-cap is our next goal. So in summary, as I mentioned, the LED lighting market can save substantial amount of energy, lower cost, and can do so by using 21st century technology to solve 21st century needs. Thank you.